Hello, and in this video, we're going to talk about something that at first glance seems pretty straightforward and obvious, but there's one little subtlety that can trip people up that I want to point out. We're going to be talking about the angles between different quantities. Now, I'm going to discuss this within the context of work, so we're going to be talking about pushes and pulls and distances, but the basic idea applies to any two quantities that happen to have a direction. So let's start with something that's pretty familiar to a lot of people. So here we've got a push pointing to the left and a direction of motion to the right. And most people would probably agree that the angle between these two things is 180 degrees. I'll note that unlike your calculus class, we're going to be mostly using degrees in this course, not radians. Degrees are actually more common in a lot of scientific literature, so that's what we're going to stick with. Now, let's take these two quantities with direction and shrink the angle between them. So ultimately, we get to a 90 degrees where the direction of motion is still to the right and the push is now up. Let's shrink the angle further, keep the direction of motion to the right, and bring the push closer and closer and closer to that direction of motion. So from 90 to 45 degrees, down to 15 degrees, until ultimately both our push and our direction of motion are both pointing to the right. So in this case, they're parallel. What's the angle between these things? So we went from 180 to 90 to 45 to 15. So once we get to parallel, the angle between the two is going to be 0 degrees because there's no angle between them anymore. They are parallel to each other. And so the angle between two parallel quantities with direction is in fact 0 degrees. This concludes this video.